So, Mark, so nice to meet you again. Just to do a little preamble here, I would love to get a chance to share this video and save it as well for myself. It's so great to meet you digitally here after getting to know something about you by reading your book. But I know I know all about you because I've read your book. But my viewers don't. And so if you do want to give a little preamble, maybe just a sort of a taste, and then we can kind of get into some stuff. A little bit about you and your theory, and yeah, that'd be great.
Okay, yeah, I'm Mark Fiorentino, author of Master of Reality, and the book is about how reality works and the theory of super relativity, which I have been working on independently here at my home as a retiree. I got into this interest as a hobby when I was a child, approximately 10 years old, upon learning that I shared the same birthday as Albert Einstein. How did that happen? Well, the nuns at my school who were teaching catechism asked us to find a saint born on our birthday, and I couldn't find one. The only thing on the calendar was Albert Einstein, so I opened up my encyclopedia and began reading about him and was thrilled, interested beyond belief about that. For some strange reason, a 10-year-old kid, you wouldn't think normally would embrace something, but it harmonized inside me. I don't know how else to
It was destiny.
Yeah, especially when I read about the unified field theory, I said, this really makes sense.
Yeah.
I hope that I learn about this before I die. And then that led to a lifetime of reading physicist books and so forth, hoping to hear the solution, which never came about until kind of an interesting accident, sort of, not totally an accident, that I discovered it on my own using the help of AI many years later, over 50 years later.
Yeah.
Actually, 60 years later. And that's how we got to this point. While recovering from stage 4 cancer, I was just playing around with AI and decided to give it some information about my theory. I fed it the truth, and then I asked it to do something it's very good at, which is derive equations, and it's a program.
Yeah.
And they had good programmers program into it the ability to do what physicists do, only much faster and much more information, plus what I added. That was the key ingredient. And amazingly, it worked. And once I cracked open the mysterious chamber, what was revealed was a series of new universal constants. Using those keys, I was able to solve enormous amounts of difficult problems. All the universal constants that I tried, I derived them all. Not just one or two, all of them. All the major ones, Planck, alpha, Newton's G, and so forth. So that backed up Einstein's dream. So there was a way for electromagnetism and gravity to emerge as aspects of a single fundamental field. And so that's my basic, crushed into a quick introduction.
And it's fascinating that it all came out of the geometric properties of our universe.
Yes. Yeah. See, the key, if you want a derivation.
What I also, was so fascinated by in your book, you talk about looking at the speed of light, which we think of as a constant, but is not actually a constant. And the way that it was derived was essentially a circuitous or a circular logic problem having to do with the length of a meter. And that was fascinating to me. That was one of the things that jumped out at me and just, wow.
Yeah, that's a measurement problem. of great concern to me to this day, because how I found out about it was my theory suggested that the speed of light, if it's dependent upon the medium, which has already been established by James Clerk Maxwell,
Yeah.
that speed of light c equals 1 over the square root of permittivity by permeability. If that is indeed the case, which I think has been accepted it is,
Yeah.
and it could be speeding up or slowing down, depending on if that medium were to be changing in some way.
Whether it's an air or a liquid or a solid or yeah.
Well, it's a quasi-elastic solid, and through the ages, it's changed. Some thought it was a liquid, some a solid, some a gas, and so forth. And they finally settled, I believe, in the end, to be a quasi-elastic solid. That was Lorentz and Einstein.
The ether, yeah.
Yeah, I went with that. But upon looking and doing research, like you do, upon looking, I found that speed of light was slowing down. And I knew it would have to be because of an increased gravitational field. Because gravity slows light down.
Yeah.
And a beam goes into a gravitational field. So this particular person, Barry Setterfield, I hope he's still alive. I don't know. I've talked to his wife through emails a few times, and he was
really?
sick the last time I talked to her.
Oh, I'm sorry to hear that.
Yeah.
Also happy to hear of your recovery as well from stage 4 cancer. Congratulations.
I mean, this time last year, I thought I was a goner.
Can't even imagine.
I mean, there was cancer everywhere, and I had to go through a huge operation.
Yeah.
Which was physically, I actually said to the doctor, do people survive this operation? When he described all the things he was going to have to do to remove my kidney, I thought, holy cow.
Yeah.
This could be it right here, but miraculously I did survive it. And we were able to get rid of the rest of the cancer using various treatments, radiation,
Yeah.
and Keytruda. And I did a lot of research about cancer.
Oh, yeah.
I did a system, a strategy, a dietary system, which I employed. And
Yeah.
I also used, what's that drug? The one they always try to ban.
Ivermectin.
Ivermectin.
Yeah. There was, I think also, because I had done a fair amount of research as well, and I heard about, because I believe didn't ivermectin, it won a Nobel Prize for...
Yes.
Yeah. And there was some that I'd found where they had combined ivermectin and, is it fenbendazole, or I can't remember the name of it, but
Yes.
What actually struck me was that in every major country in the world except the United States, there's a protocol for antiparasitics to essentially deworm not only your animals but people also, but we don't do that here. And I think, and I don't know if this is true or not, but there was some sort of link between parasitics and cancer, and that there was a connection, because essentially ivermectin is an antiparasitic, and so
Right, but it does more than that.
Yes.
I found a study where they used it with Keytruda.
Oh, okay.
And it was very effective.
And I don't know what Keytruda is, but
Keytruda is a pharmaceutical product that fights a lot of different cancers by powering up your immune system.
oh, sure, okay.
In layman's terms, it boosts it, if it's lagging, and it gets it to recognize the cancer and eliminate it.
Yeah.
So I ate all kinds of supplements and things that helped that happen.
That's great. Yeah.
So between all of those things, somehow it worked out. I can't say it was this thing or that thing, but
Yeah.
I was using a buckshot method,
Just do it all, right?
because this is, my life. I can't try one thing at a time until I die.
Right.
I just need to get it. I used what would be a massive dosage of everything together.
Yeah.
Individually, small doses of this food and that supplement and so forth. But together, all across the day, I'm taking and eating a lot of stuff that fights cancer.
Right.
So it appears to have worked, and it's given me more time because I needed more time, and I think that's part of the equation.
Absolutely.
If you have something important to do, life finds a way to make it happen.
Yeah.
And that's a spiritual belief in my...
I agree. I believe that everyone comes here with a purpose, and we have to find that life's purpose and make it. Either we succeed at that or we don't, and hopefully we do. But free will comes into it with what we choose to do.
Definitely.
I agree. And it's interesting because when I was kind of doing a lot of my research on metaphysics and kind of going down the rabbit hole on various different issues, I had kind of an existential moment where I was thinking about, the whole question, is there free will? Is there no free will? I'm sure you've thought about this yourself. But my conclusion was that both determinism and free will exist simultaneously because you have an infinite number of universes, and in every universe, everything that can and will has happened. And the way that you have free will, so determinism is true because everything that can happen will happen somewhere. But free will comes into it because your consciousness is similar. If you were to imagine like looking at a bulletin board with different photographs, and your consciousness chooses which photograph you're looking at. And so I believe that every moment in time, we are making choices which universe we are stepping into for that moment of time. And so that's how we have free will and determinism simultaneously.
Well, I've had a lot of discussions with very famous psychics and mediums on this topic, as well as reading for that information and videos of NDEs, and I have found it, and they unanimously say both happen together.
Yes.
Free will and determinism. So
it
makes sense. You need the free will so that this dreamlike thing we're going through has real meaning and can create experience, whether good or bad or positive or negative. So there is a life plan, and I've heard that from NDE people too.
Absolutely.
They remember before they were born, and then they report that memory of how they went to classes ahead of time, how they were in front of a council that discussed their life plan and what was going to happen. And
I remember reading accounts. There was I think like a child in India who ended up going to a different town, and they were able to locate the house they lived in.
I read that one.
Okay, so you know that one, or the little boy in America who remembered, was drawing all these pictures of fighter pilots from, the World War I, and he, eventually was able to identify the plane and the ship that he had lived on in a previous life, and they found the grave where his, he had actually died in this previous fighter. It was unbelievable. It was crazy, but it was he knew exactly, what type of, airplane was used in this squadron and all this stuff. And
Yeah, unfortunately, many scientists won't take testimonials as evidence. So that's why it's so hard to prove what they want is somebody to be able to, in a lab, set up an experiment that's repeatable in other parts of the world, not only the one lab, that confirms the afterlife. And, I don't even know exactly what that experiment would be.
Well,
I don't know if you've ever seen the movie Brainstorm. But
I haven't.
That would have, you should see that one.
Okay, yeah.
Technology that you put on your head, and it takes everything out of your consciousness and puts it into the computer. So,
that's fascinating.
Video. You
Yeah.
get a video and
This is going to key into some stuff that I actually want to show you and we're going to talk about today. So this is great.
it allows another person to experience everything, the smell, the sense, the touch, everything when you put on the headphones and replay the experience.
Now we're getting into like the Montauk chair and the chronovisor territory, which we can talk about as well. I don't know do you know what those are or have you heard of them?
I know Montauk, but I'm not an expert on Montauk. I do talk about it in the book.
Yeah.
It's the fringe part of reality that I don't get into too much, other than discussing that.
Yeah.
It's possible.
Yeah.
And what the real truth is, who knows? Because there's a Bureau of Disinformation that's been pushing stuff out for decades. And,
Yeah.
The dark.
You've got to be able to sift what is and what isn't, and
yeah, some might be real and some not. Some of these guys that come forward have been really caught lying.
yeah, absolutely, yeah. And it's you always got to take it with a grain of salt, of course.
I don't know what precisely or for sure happened there, and I know something happened there.
Yeah,
and I would love to know.
I read a lot about that specifically, and that whole part of history was then spun out into the TV show Stranger Things, and that's all based on Montauk
Right.
and the Montauk Project, and before that MK Ultra, and all of that through U.S. history. That for instance, MK Ultra was publicly recognized by President Clinton, who apologized for that. That's something that they did state was a real thing that did happen. Essentially experimenting on, the U.S. public, which was not great.
Oh, yeah, they'd probably be doing worse.
Yeah, I mean, it's a whole rabbit hole, and but at any rate, getting back to your work, with where you are ready to take this, now that you have used AI to help really, derive the equations that are necessary to use it in a practical sense, what is your next step?
Yeah, this is an important thing. I'm glad you brought that up because, announcing right now that what we're talking about today is of the utmost importance this is the battle for reality.
Yeah.
What's really true and what's not.
Yeah.
And, like you and I, there's more of us out there that wonder, well, does this really work?
Yeah.
Physically, the mechanics of it have now been worked out as Einstein dreamed and hoped for. It happened in a funny sort of way while we were recovering from my surgery and so forth, but it's happened. So now I have in my lap all this information, all these papers, these technical papers,
Yeah.
when combined, are immensely powerful. It's a complete theory of everything. So I'm announcing that has been done, it's been completed. And now I'm working on some of the finer points having to do with a new type of gravity and anti-gravity, and I know a lot of people are interested in that.
I know you mentioned, gravity 2 and, linear gravity, I think is what you'd mentioned.
Right.
And that linear gravity is a transverse wave. Is that correct? It's not longitudinal?
It's transverse.
Because transverse would be, like up and down.
Transverse is something like
Electromagnetic waves are transverse waves, for example. Like sound waves would be
light is a transverse wave.
Light is also would be a transverse wave, but like sound waves would be a longitudinal wave, for example.
Yeah.
It was something that
I'm struggling because I think of it as a contraction.
Yeah, well, that's a transverse wave. It goes up and comes down, and it contracts, via permittivity and.
Normal gravity is coming down around. Let's say you have a ball, and that thing is very heavy. It's got a lot of gravitational field around it.
Yeah.
It's all pointing in all the way around. It's not linear.
It's uniform.
Yeah, it's a uniform field pointing toward the center in all directions. Whereas this new type of gravity comes out of the dipole, either positive and negative electrostatic field or a positive and negative magnetic field.
Yeah.
Which makes perfect sense if you realize the fact that in UFOs they've been described as either emitting immensely powerful magnetic fields or
well, they're counter-rotating fields. So you have one field spinning one direction, the other field spinning, the counter-rotating.
Yeah, there are spinning aspects, but you can see that is true when you look at crop circles. And you
Yes.
lay down.
It's the toroid. That's the donut shape essentially.
I think they use the spinning feature for stabilizing the craft.
Yeah.
Hover mode.
Just for a hover. Yeah, exactly. And I remember watching the video with Bob Lazar where he talked about using the pressure wave to pull it in one direction or whatever.
That's what I call the slip wave.
The slip wave, which is what is in your book, yeah.
Yeah, that's what gets me interested and keeps me interested in Bob Lazar.
Yeah,
I thought he was a crackpot, but
his I remember I saw his interviews, the early interviews with that reporter. What was his name? I can't remember, but he had.
I know who you're talking about.
Yeah, he'd won an award, for being a great reporter. But at any rate, Bob Lazar had a ring of truth to him that a lot of people didn't, in my mind.
Well, I have a theory about whether he really worked at
S4.
S4, Area 51. I don't know, but I can tell you that his explanation of anti-gravity really matches super relativity. And I don't think that's an accident. I don't think he just made that up.
Yeah. No, I agree. I think it makes...
With,
well, what I was going to ask you about is, are you aware of... what was the guy's name? I have the video pulled up for you. There was a tech... I don't know if he's a multi-millionaire or billionaire, but he basically dropped out of the industry to personally follow, this desire to create this machine, which basically would, essentially be a Stargate. His, let me pull it up here because I have it on the tip of my tongue. Joe Firmage. Have you heard of Joe Firmage before?
I may have read about him, but I don't really recall him.
So let me share.
What I'm thinking about is John Lear.
Well, John Lear, I saw the John Lear interview, but Joe Firmage was, he was a, I don't know if he's a billionaire or a millionaire, but anyways, he used his fortune. He left, he had this complete change of heart, and he wanted to pursue, making this device essentially to, try to create anti-gravity. And what's interesting is did you ever see the movie Contact?
Yeah.
The machine is very similar to that. It's sort of like a gyroscope or a wheel within wheels, which makes sense because you're precessing in multiple different fields of reference. And basically you're creating an intense either electrostatic or magnetic field, which is a rotating toroidal field at increased levels of voltage. But at any rate, I wanted to show you the video. Do you mind if I share the screen?
No, go ahead.
Okay, great. So here it is.
A few years ago, we commenced testing.
So I'm going to pause right here. So that right there is showing the mass of the object. And what he's able to show is that the mass actually, when it's being activated, will decrease to the point of creating negative mass, which is required for anti-gravity. And so let me just kind of continue here. Now, did you see that little blip at 41 seconds? I'm going to see if I can get the exact frame. Right there. Did you see that? There's that little kind of bluish hole.
No.
Hang on. It's right at the top of the frame.
Oh, yeah.
We commenced testing of
There. Do you see it?
Yeah.
What is that?
I have no idea.
Now, I believe that this is, I mean, it could be crazy, but if this is really working as it's intended, this is the beginning of a wormhole, which could be created by using an intense magnetic or electrostatic field. But I'll continue the video here real quick.
of entirely new means of propulsion and energy. By 2010, after 5 generations of test systems with extraordinary video and data acquired with the finest means and at great cost, we believed a breakthrough was at hand. The implications were profound.
And it just goes for another minute or here.
Three further generations of the device have reinforced and refined the potential of this breakthrough.
And there's where it's showing the gravity field effect on the mass.
Lifting 200 pounds at the center of matter of a machine with less than a light bulb of energy. True free lift.
And so that's magnetic levitation, which we know is possible based on the maglev trains that, use supercooled superconductors. But, to create this effect without, a superconductor cooled to almost absolute zero would be incredible. I'm just going to stop sharing real quick there. But so anyways, what happened with him, he kind of fell out of the public eye after he sort of went and tried to create this device. And then he just sort of disappeared after that. And I don't know if they were never able to get the funding or, who knows. But at any rate, I always thought it was interesting because, those are the types of forces you would need to create a Stargate.
Well, yeah, and I talk about Stargates in my book too, but I use a completely different method. And it's not concisely defined. It's just my ideas and theory on it. Basically, you're going to have to accelerate something to beyond the speed of light in order to couple of time and space, and so that you can open a gateway, a portal. It's basically what you want to do between your dimension, your reality, and some other dimension or reality.
Correct, yeah.
You have to master space, and that device, maybe with the spinning, I don't know if it's magnetic fields or just inertia going on there, but would be their way of doing that. I don't know. I built something similar to that in my first pass for detecting.
Oh, wow.
It's in the garage. It's a device, microcontroller controlled. It's got some digital circuitry, microcontroller and so forth, along with 6 magnets that I would turn on and off in sequence. And I didn't need the spinning thing. Yeah. Because I'm fully electronic, so the field's going.
Oh, wow. I'd love to see it'd be so cool.
I would weigh stuff in it, but I couldn't find any difference in the measurements, and I was disappointed in it that I didn't really find it. I thought the speed of this circular thing would have, because there's so many people like what you just showed that imply there's something spinning going on, plus I'm thinking crop circles.
Well, to me, it goes right back to your book where, you talk about, vortex mechanics are required to create a bubble within the ether field. That's how you do it, is you create a vortex to force in a bubble into the ether through which the speed of light will increase dramatically because there's no, or much less, a lower of the forces of permittivity and permeability.
Well, vortex does take a big role in everything that I talk about, because particles are vortexes, basically, twist geometry.
Yeah.
That particular method, I don't know for sure will work or not. I don't know the details of the design. I don't know the theory because they're flashing stuff really quick.
Yeah, it's a very, it's hard to follow video. Yeah. But at least got me.
I've seen other similar, there's a Searle effect. I've seen other similar types of things.
Yeah.
I'm sticking with my theory.
Oh yeah, absolutely. I just wanted to.
Know, works based on my papers, which I highly recommend people go out to research and read. I am hoping that there are physicists or out there listening to this show, or somebody who knows physicists that can read these papers and understand them and realize how incredibly important they are.
Yeah, because in my mind, I mean, that, little video.
That's what I'm trying to do. That's what, to me, this show is about today. Trying to get people to realize the unified field theory is here. It's done. You can read all about it. And it must be accepted into the mainstream scientific world. But that struggle isn't going to be easy. So far, I'm not having much luck.
Yeah.
Still working on writing papers that I hope can be peer-reviewed, and I have a friend who's helping me with that. But there's a lot of bias.
Yeah.
There's a lot. Like you want to talk about the ether. If you bring up the word ether to a regular physicist,
they immediately shut down.
Automatically dismissed.
Yeah.
As you can't possibly be right.
And it's just, it was just the diversion of not taking into account in the Michelson-Morley experiment that it was a dynamic ether and not a static ether. That was where the problem came from, right?
That's partially true, yeah. The ether can be bent in small deformations, contracted, expanded, twisted.
Yeah.
Basically, when a particle moves through space, it's not the ether that's moving, it's the configuration of the ether. In other words, the particle is completely consubstantial with the ether, is one and the same thing.
Right.
So what's moving is this twist, which is a electrostatic field. And that field, like a ripple, moves through space. It doesn't displace it.
It moves with it.
Transforms into that shape as it moves. And it's interacting with the space in that way. So they weren't that advanced in that thinking at that time. They were thinking still Newtonian stuff and Willian things, and they didn't have the right model for the ether. Then they were close.
Yeah.
But then the Michelson-Morley experiment came around, and that further confused the issue. And then Einstein knew about the Michelson-Morley when he was writing Special Relativity, and he said, I know they're going to announce that they couldn't detect the ether, so I'm taking it out of my paper.
Sure.
And that's what he did. He
that
said,
that was where things went off. Yeah, off the rails.
And so that's almost what I have to fix first before I can introduce the paper.
Yeah, I think if you have a physical demonstration that forces people to take you seriously, then they will listen to the equations.
Well, I'm working on the slip wave detection and so forth, but you can, like that video you just showed me.
Yeah.
A physicist would just rip it apart.
Sure.
And I know, what I'm doing, they can find, like they did for Thomas Townsend Brown, they ripped his stuff. He really made a truly great.
Oh, I remember. Yeah, I read about T. Townsend Brown and what the, how he was discredited and.
It's just ionic wind, and it's not a real gravitational force. And
did you read about Otis Carr as well and Ralph Ring?
No.
No, Otis Carr, I believe, was an assistant of Tesla. I could be mistaken, but I believe he was, and what he learned, and then he went on. But anyways, getting back to your point.
Yeah. So I believe that we need to reestablish the belief in the ether, and know that it's a real thing, and then find a way to test it, which I have about 5 or 6 different ways, experiments that are better than some are similar to the Michelson-Morley, and some are a bit different, that we could test and verify the ether. But again, as soon as you bring it up, they don't want to hear it.
Sure.
There's like for instance, the known problem of the decay of isotopes change every December, January. That can be explained as due to the Earth moving at its fastest.
Mm-hmm.
Most likely you would detect an ether wind in changing the time, the process of nuclear fission or whatever type of isotope decay we're talking about.
Yeah.
It's changing the timing because we're moving faster.
Right.
And also read about people in CERN, and I wish I kept this paper. I should have. It was very, very important. And I said, well, I could find it again, and I went on to other work, and now I can't find it. But this guy was a maintenance guy in CERN.
Mm-hmm.
December, January, the beam timing went out, which is what my theory predicted. So I started looking for anybody talking about that.
Yeah.
And I found, sure enough, late December, early January, when the Earth is moving the fastest, the beam timing in the CERN particle generator,
mm-hmm.
in the east and west tunnels most likely, goes out of whack because it's, the beam is going, the particle beam, let's say neutrons or protons, has mass, and that means it has inertia. So in the way it's being pushed around, it's not like the photon whose motion is totally internal,
yeah.
independent of anything else.
Right, because it has no mass.
Yeah, this stuff does, and it's being pushed externally. So any kind of inertial interference is going to be detected relative to the absolute stationary background of the ether.
Yeah.
Sure enough, they did detect a problem, but they're not attributing it to the ether. They would say, well, I think it's groundwater.
I remember, yeah. CERN is interesting for other reasons too. Have you about the Mandela effect? Yes.
Yes.
Yeah. There's some of the readings, where people were believing that what CERN was doing was creating the Mandela effect, or having some sort of effect on it. And I've experienced Mandela effects in my own life. One that I remember, which is kind of funny. There was a movie that came out, I think in 2012 maybe, or maybe earlier. It was the series of Underworld movies with the actress Kate Beckinsale. But what I found was, when I looked it up later, the actress's name was Kate Beckinsale. But I remember specifically that it absolutely was Kate Beckinsale with a D. And, I looked it up, and, sure enough, there's a little bit online where people have noticed this also. And this is a very minor Mandela effect, but, the bigger ones that, you hear about are like the Fruit of the Loom logo, with the cornucopia disappearing, or the Berenstain Bears versus the Stain Bears or whatever it is now. Those big changes, I guess.
Yeah, and again, that could be explained by other things. I had a problem with the Jiffy peanut butter.
Oh yeah, Jif and Jiffy, right? Yeah, that's another one. Yep. But what's interesting is there was a kid. I guess his name was Max Lohan. I think maybe, I don't know. He fell out of the public eye, but he was working with trying to redo some of Tesla's experiments, I think, when he was a kid. And he, his explanation was that the huge experiments that CERN was conducting was literally creating Mandela effects in our universe. How, I don't know, but...
Well, there's a lot of conspiracy type ideas about what CERN's doing and what.
Yeah.
I'll give you my take. It's much more mundane.
Sure.
It's much more accurate.
Okay.
This is the way physicists these days makes a living. If you're a particle physicist, you need a collider
Yeah.
to make particles.
Sure.
And it's collision between particles that makes new particles. So all they can do is play around with the energies, increase the energy, and hope, and then statistically analyze the fallout from all these collisions, and hopefully come up with some new particle. And when they do, they get a Nobel Prize, they have champagne parties,
Sure.
and everybody collects their check, and they're all happy.
Yeah.
And that's become a way of life for physicists. So my theory, if it's correct, kind of puts an end to that, because it's really unnecessary. Because that road, the quantum mechanics road, that's basically saying everything is about a particle to particle interaction, is no longer true. And my theory, as you realize, it's about the particle to space interaction.
Yeah.
That creates the forces, gravity and magnetism, and through the motion of unbalanced charges.
Yeah, well, I mean, like a wave is kind of like a deformation of the ether field, correct? Or maybe I'm misunderstanding that.
Yeah, it is. Any type of magnetic or electrostatic wave or gravitational wave, they are all different types of deformations of that field.
Mm-hmm.
It's the fundamental field that Einstein was talking about. And he used to believe in it up until Michelson-Morley.
Yeah.
And he didn't want his theory thrown into the trash, so he discarded it when he announced it. And so people, well, he got the math right. The answers work when we do these experiments, and so therefore he must be right. But ultimately, his interpretation was too abstract, and it's not correct. And he did the same thing with gravity too. In the gravitational field equations, he kind of made it about bending of some sort of space-time continuum, but he gets a little iffy, and he doesn't say it's an ether unless he talks to Lorentz, and in his speech to Lorentz, he says, well, in that sense, the gravitational field theory and in my theory does suggest that there is some sort of ether.
Yeah, absolutely. I think that
was to please Lorentz, because he was making a speech to him at Leiden.
Yeah.
But in general, he kind of made it look like, well, space isn't really real, it's just
geometric
ways to explain all this stuff that's happening. So what my theory does is brings back the real physical meaning, that it's a substance that's real. As a matter of fact, it's the only thing that is real.
Have you done much research on cymatics?
No.
Cymatics is it's patterns that sound make. So if you have like you know what I'm talking about? It's sort of like sand moving in certain patterns based on different frequencies.
Demonstrations, very interesting.
Yeah, it's fascinating. And what they found out is that almost all of the cathedrals that have those beautiful windows, those are cymatic patterns. And I just was curious, where cymatics would connect in with superrelativity. Because I'm sure there's a connection. It has to be, right?
Well, the geometric dynamic geometry of the trefoil knot is at the heart of the universe.
Mm-hmm.
It's the basis for all material substance. And the neutron and the proton, the quarks are moving in the trefoil knot pattern. And I was trying to work with the people that I discovered the trefoil knot pattern from, because I was thinking Einstein was looking for a dynamic geometry. And I know that because he was very interested in the Ehrenfest paradox, which was talking about rotating like a cylinder or a disk and how it contracted at the perimeter.
Mm-hmm. Centrifugal force, is that right? Or centrifugal force, is that what you're referring to?
He had credited to that, but it also has to do with the contraction of Lorentz contraction.
Oh, the Lorentz transformations?
So you're using special relativity to possibly create the cause for general relativity and gravity. And he was absolutely right. So when I saw that, I said, I got to look for a geometry inside of the neutron and the proton that's moving. And I said, well, it does have 3 quarks in it. Now, he didn't know that in his time.
Yeah.
So he was trying to guess at some kind of, some sort of geometry. So it was guesswork, and it was way off, apparently. But I know about the quarks was after he passed away, in my time, they learned all about the quarks. So I says, the quarks are moving in some sort of special way, then I have to find that. And
accelerated motion, because they have mass, right?
Accelerated motion, yes, right. And I looked into near-death experiences, thinking maybe the Father in heaven wants to send us a message through one of these people.
Yeah.
So for anybody that discussed the geometry, and I found somebody, they said they saw this trefoil pattern. And I thought, that makes perfect sense. 3 trefoil, 3 quarks.
Mm-hmm.
It's got to be, and it makes sense that they would move in this tight circle like that with this knot, which holds it together in reality.
Yeah.
This dynamical geometry is the perfect explanation for mass. And I wrote papers using the formulas for the trefoil knot and using acceleration formulas. And sure enough, I get the right prediction for the neutron and the proton, which has never been done before.
Which is amazing. It's profound. And also,
it is.
it's incredible. I remember reading that part of your book where you're talking about, how, the neutrons, would have to have a way to, essentially create stars, by, I'm struggling here, so you got to help me, with kind of becoming neutronium, which we've never proved yet, but we've
seen neutron stars. We know they exist.
Yes.
They don't show up very well because they're black.
Right.
and they don't reflect light. So you can only see them as radio transmitters sometimes, because they're spinning so fast.
Yeah.
The gases around them spin and ionize, and they put out radio pulses, and that's ways that we have detected them. There's sometimes when there's other gases around and they have a certain glow that you can see. So they're out there, and all I said in my book was basically, well, we know stars of certain sizes, when they have a supernova, what's left is a neutron star. All I said was that neutron star was there all the time. The explosion came from runaway fission and created a pressure wave pushing the atmosphere away from the neutron star, which had gathered the gas in the first place and ignited the fusion process that made the star. Otherwise, our gas is just floating around in outer space with the negative pressures of the atom and so forth. They're not going to just fall together into this immense glob, pulling mass together as they do. It's just not the gases, the atomic pressures are pushing away, the electromagnetic pressures much greater than their gravitational field.
Yeah.
So how did these stars get formed? It must have had a gravitational source, a big one. Not only can gather this atmosphere, hold it there, and crush it to the point where fusion happens. It all makes sense.
Yeah.
Makes better sense than the astrophysicist claims that, well, what we have is dust and gas in outer space, and it sort of tied knots, and they fell together, and then we have a star. That's laughably bad.
Yeah.
And they should have thrown those guys right out.
Well, and you said, there needed to be an elegant way for, the neutrons to be able to phase shift, or I'm struggling here because my verbiage is not, I remember reading about it, but my language for explaining it had to be able to happen in about 15 minutes, and I was hoping you could.
That's the decay. The beta
Yeah.
decay of the neutron happens in around 15 minutes. So I says, wait a minute here. This reeks of intelligent design. I says, that's no accident. If the universe were to have started with nothing but neutrons, which is likely thing, because I'm saying, well, you have neutron stars, we know they exist. We have black holes, we've seen them. All a black hole is a neutron star that's so large that the gravity becomes so strong, it goes dark, and you have an event horizon, and light can't go out. And so it's a neutron star that's maybe 8 solar masses or greater is enough to create a black hole. But it's still a neutronium device. It's infinitely strong mass. It's not infinitely strong gravity as the equations suggest that break down. They're breaking. Whenever you have infinities, that's not good in physics. It's a ton of equations. And instead of accepting that and knowing that there's an incompleteness in these equations, they just try to, somehow it is that way, because that's what it says. But yet, obviously, if you had an infinitely powerful gravitational pull, it would suck the whole universe in.
Right.
At the speed of light. And that has never happened. And it will never happen. But what is happening is there are immensely large black holes out there. Billions of solar masses. We're getting pulled toward one at about 1.3 million miles an hour. That's not slow.
Yeah.
We're our galaxy, Milky Way, Andromeda, and a whole bunch of others in this area. We're all heading toward this what they call the Great Attractor.
Yeah. And in the fullness of time, there will be this giant cosmic egg, essentially, of all the black holes merging.
From neutrons only, because this stuff, when it crushes down into it, it becomes neutrons. It's the only protons can't be crushed to this great depth. The electromagnetic force isn't going to allow it. But the neutrons can, because their electrostatic forces are balanced. So you can get them much tighter together, and, which is perfect. Just what is needed to create a black hole and store all the matter and energy of the universe. Why I thought that this is intelligent design, the decay of the neutron, I said, well, in the Big Bang in my model, the black hole reaches such a large size that the internal heat goes up to trillions and trillions of degrees, when all these quarks that are so close together are brushing by each other and they're shooting off photons. Point where you have this immensities that eventually pushes this black hole apart, so the explosion vaporizing much of the black hole material, neutronium, while allowing all these chunks, spheres of various sizes to expand at the same time. Within 15 minutes, which is what you were talking about, the neutrons become the perfect ingredient, hydrogen. They become a proton and an electron. And I says, that's not an accident. That's just what we need to start a universe and to build one. Because now we have hydrogen, which is the building block of all the stars. And we have it in great quantities.
Yes.
We press them together again. We need a system that will gather that gas and form stars and form galaxies. And then the bigger neutronium spheres that came out from this humongous thing, it was millions of light years in size across, with all the matter and energy in the universe in it. Everything that's needed to restart and recycle the universe is in the neutronium's core of this black hole. And so we have everything we need, and it's all neutrons alone is the only thing that's needed. The gas becomes a plasma of hydrogen, which then is gathered, stars are formed, galaxies, there's a big one in our center of our galaxy that gathers the stars into a group. They're all spinning around because that neutron, that black hole, is also spinning rapidly, dragging space around with it, which affects the stars and puts them all in motion. It's like a giant cosmic ballet, a dance.
It is. If you look at it from a way out, you could think of, the reforming of our universe expanding and contracting into, a giant cosmic egg is kind of like a heartbeat. If you think about it, it's on an immense scale.
And the beauty of it is, it never ends. It's in this way, that's a connection to God, our Father.
You'd have to create like a Dyson sphere if you were gonna, slow it down.
The universe is eternal.
Yeah.
But as a material object, it lives and dies, reborn.
Ever changing. Yeah.
And that gives us spirit beings a chance to continue to come down and evolve and learn and
have experiences. Yeah.
It's a giant dance. I don't know, or I call it the shared dream, that God has intended all of this.
Yeah.
And He made all the rules, and they are immutable. He is immutable.
I believe that our lives that we live are for us, in the sense that our experience is an experience, that's not happening to you, it's happening for you, so that you can learn and experience. And
or both, really. It's happening 2 and 4.
Yeah, simultaneously, I guess. Yeah.
It's a marvelous. I don't know if I could classify it as just a device or experience. I ponder this a lot. This is something that I think about a lot. Why we're going through all this, but
sure.
I guess it has to do with learning and struggling. There's no struggling in heaven. Everything is perfect and happy. And maybe it gets boring. I don't know. It's not boring here. No. This place is really hard.
What's the phrase? May you live in interesting times, right?
This stuff is tough.
It is, yeah.
I've gone through some serious diseases.
Yes.
Heart attack, cancer, kidney stones.
Yeah.
You name it. Oh, God. Please, Lord, no more.
Yeah, I can't even imagine. And I'm so sorry what you went through. Yeah, so, moving back all the way to kind of your next step, so you want to connect with physicists who are willing to take your work seriously.
In order to make things move forward, I would like to work on anti-gravity crafts, spatial bias drives.
Yeah.
I know where all the pitfalls are, and I know how to build a device, and there are some certain dangers in traveling at the speeds these things can generate. You have to be within the slipwave bubble. If you're not within that slipwave bubble,
you're instantly done.
Your inertia is You can't go from 0 to 50,000 miles an hour in less than a second and survive that.
Correct. Yeah.
You're in something.
I think in that situation, you would be dead before you knew it.
Yes, you would.
Literally.
You can't get toward the speed of light or beyond.
Yeah.
Of being in that same bubble that prevents you from feeling inertia.
Yeah. You want to make sure you have backup power so it doesn't just cut out.
Because the Lorentz transformations are going to say that your mass is going to build toward infinity.
Correct.
If you don't have this.
You would spaghettify, I think, right?
If you use rockets to go forward at the speed of light, which we have no rockets that powerful, but if you could, that would be fatal.
Yeah.
Not survive.
Well, I mean, that's why, when you look at the sightings of the UFO craft, that they have, and they stop on a dime and then they go this way, and it's only possible with the slipwave.
Yeah. You have to pull space apart so that and your gravity comes from a slip wave generator. The other gravity's moved out of the way. Your gravity can.
Well, I mean, you're just creating a vortex which pushes out a bubble into the ether, and you're inside that, and then you're moving around with that, right?
Basically, but it's the trick is you got to pull space. The twisting and the rotating causes space to thin out.
Yeah.
And
then you need to have,
you got, magnetically speaking, you got forces going in the North Pole and coming out the South Pole, which, by the way, is exactly opposite of what you'll see in pictures in textbooks, which is what my experiments now are revealing.
Oh, interesting, yeah, because it doesn't go in the north and out the south, it's the opposite?
No, without the north, and I said, the day I discovered it, I said, oh no.
We got it backwards.
Something's wrong, something wrong here, and I said, wait a minute, I have to go back in time, figure out who determined the flow of current, which direction it was, and see if they got it right.
Okay.
So I took in the dug and I went all the way back to Benjamin Franklin, who was the first one to capture charges. Bottles, with basically capacitors, and then he would make the spark, and he guessed at what he thought he saw the current moving from the positive to the negative charge. And it turned out it was the exact opposite. But then everything for the next 150 years after that was based on current flow in the wrong direction.
Oh, wow.
Right hand rule, the magnetic field rule, all that, they drove all the lines of force
backwards.
Calculated from that first guess.
Okay.
And it was wrong.
Right.
And some textbooks mention it, especially electronics textbooks, the current flow is one way, but the reality is the electron flow comes from, we know that from J.J. Thomson and his discovery of the electron, and then determined,
do you know?
Negative pole into the positive pole. So now it makes sense. The experiments I'm seeing make sense.
Yeah.
Lines of force are actually going in, which would be the contraction in this direction going through the magnet, coming out to an expansion in this direction.
Wait, I thought it was the other way, though. I thought it goes through the South Pole and up out of the North Pole. Is that right?
That's the way they draw it.
Oh, okay. It's wrong. So it goes in through the north and out from the south. Is that right?
That's the way I draw it. That's the way I believe it really is.
Yeah.
And when I put magnets and measure their weight, electromagnets especially, and I turn on the power, they get lighter. They shouldn't get lighter. That's not what should happen with a magnet when you energize it. If anything, it should get heavier. Especially if there's any metal and you're pulling it down toward the metal. Now, if there was something above it, which in my case, there's nothing for many feet.
Yeah.
Nothing for it to pull up on, but there is a metal plate below it. Giving it enough space where the magnetic field is very weak here, and it would have no effect.
So it's not like a repulsive force then?
Exactly. In order for it to get lighter, there must, if it's truly an anti-gravity effect, there's a repulsive force going on somewhere.
Yeah.
And it's negative side.
Right.
So then when I flip the poles and do the experiment again, which is very easy, I just switch the wires in a power supply.
Yeah.
And redo the experiment, it's still lighter, but not by as much.
Interesting.
Well, that's because you have the thrust working with you when the North Pole is up. It's pulling up and pushing up.
Okay.
When you switch the wiring, it's still slightly anti-gravity on this side, but the thrust is going down.
Okay.
So you've got a little bit, a tiny, itty-bitty, a little thrust of the gravity tube.
So it's lessening the effect?
But the overall weight of that magnet is still lighter because of the anti-gravity field side.
Okay.
So it still weighs less. So this is all suspended on a column of plastic.
Sure.
That's not magnetic. And this is exactly what my theory predicted. So I'm actually getting the measurements the theory predicts, which is very encouraging.
That's great.
Pete Brown did the same thing with capacitors, and I'm going to do an experiment with capacitors too.
Yeah.
I should see the same thing. When the positive pole is facing up, that's when it's going to be its lightest. That's the way the thrust is going.
So the positive is like the North Pole where it comes out of, the magnetic
North
lines
pole.
of force?
The North Pole of a magnet is the positive.
It's the positive. Have you ever read any of the work by Ed Leeds-Skalman? He lived in Coral Castle. Are you familiar?
I heard of him. I've had discussions with other people about him. And his
Oh, okay. I just, because I know he wrote a book on magnetics, and I don't know if he had an incorrect view on it, but it was at least an interesting and individual.
Well, yes, definitely. He's had some really great engineering skills for sure.
Yeah. Yeah, so I don't know, if his views were different than Einstein's or Tesla's or... Yeah, he was talking about...
I'd have to read it and,
Yeah, I think he was talking about monopole magnets, and I don't know if that's even possible.
I haven't figured out a way to make that happen.
Yeah.
I think it's an interesting idea, but...
He was really interesting because apparently he wrote 2 books. One was on magnetics and one was, I don't know, something else, but they had coded, like, I don't know, hidden things in them.
There is one way you could make a monopole magnet. It's kind of kludgy, but...
What's that?
What you do is you take 2 magnets, north-south pole, and then let's just say you take the North Pole of one and the North Pole of the other, and you glue them together.
Mm-hmm.
You have 2 south poles.
Yeah, I guess.
Monopole, I don't know, maybe.
Yeah, who knows?
Just take south poles stuck with the North Poles glued together,
Yeah.
Play around with that, because it's just an interesting idea.
It's an interesting idea. And the other guy I was going to say is, have you talked to Eric Dollard? Because he is, or have you heard of him? He redid all of Tesla's experiments. He was able to redo all of them, I guess. But he's a very interesting fellow, and he worked a lot with vacuum tubes and, longitudinal waves, which I guess is something to do. I don't know. I don't understand, capacitance and inductance and all that stuff. It's kind of, I just don't know much about, like that side of it. But he seemed like a very smart individual who, yeah. You guys should talk to each other,
I mostly work in the realm of transverse waves.
Oh, okay. So you don't work with the longitudinal waves that like pulling and...
I mean, I guess you could say what I'm doing now with the magnets and the other stuff is longitudinal. I'd have to look that up and verify that.
Do you know what a longitudinal wave is?
What?
Do you know what a longitudinal wave is?
I have it written down somewhere.
Okay. So imagine
in line,
Yeah, imagine you're holding a rope and I'm holding the other end of the rope.
You whip it.
No, I pull it. And if I pull it, you feel it instantly. There's no time delay, because if you have a transverse wave, it has to do all of this nonsense before it gets to you. But with a scalar wave or with a longitudinal wave...
I studied it in a while, and I kind of got it. It's a little fuzzy in my head now, but I'll have to restudy that again, because that comes up in conversation.
Yeah, it connects in with resonance, where you have essentially instantaneous changes based on waves that have no time delay. Tesla was working on it, using it to, sending things into the ionosphere, and then, that's all connected to the HARP project in Alaska, and whatever else, and yeah.
Yeah, I mainly study the transverse wave because why? There's one thing that's very important about transverse waves. Primarily, they're in solids. There's one exception with the wave of ocean wave, the top part could be considered a transverse wave, but then the medium is moving.
Yeah.
It's purely, and I Einstein said primarily you see in solids.
Okay.
And so that supports the ether theory.
Well, and electromagnetic waves are transverse waves.
Yes, and they're flying through space. So that implies that space is a solid.
It has to be, otherwise there'd be no distance.
Which I say in my book, and which I've said in papers. Yeah, if there's no different distance, then there's really nothing to traverse.
Right.
And the distance, let's say, from the sun to the earth would be zero if there was truly space was made of nothing.
Yeah.
Empty and void and made of nothing, as some scientists say.
Yeah.
It takes so much time, like 8.5 minutes or so for light to get from the sun to the earth.
What's it doing, right?
Traversing something real.
Yeah.
That's there.
Mm-hmm.
Otherwise, it would instantly, if there was nothing there, the distance would be equal to zero.
Right.
And the speed would be infinite, and there would be instantaneous transmission of light throughout the whole.
And that's kind of what you get at when you have the ability to create that bubble within the ether, because the speed of light goes to infinity if there's no resistance, correct? If there's no permittivity and permeability holding it back, it would
The smaller those numbers get, the faster the speed of light. So that's kind of what the slipway principles is based on.
Yeah.
You have to create a spatial bias drive, a field that reduces permittivity and permeability. It's
right.
It's the math is already there.
Yeah.
Do the calculation yourself and make those numbers smaller. They're very small already. And that's why light is so fast, because you're dividing a very small number into a large number.
Yes.
You get a really big number as the velocity. If you could shrink permittivity and permeability, pull space apart, makes it shrink.
Right.
Then you can go faster than the speed of light. So you could use a magnetic field to do that, or you can use electrostatic field to do that.
Or you'd be going as fast as the new speed of light, because the speed of light changes based on the medium.
You can go as fast as you want.
Yeah.
And that would be thousands of times faster than the speed of light. And that's the only way.
Well, if you bring it back to the kind of the spiritual level, when people have these near-death experiences and they're moving at the speed of thought, I mean, that's kind of the fastest you can move, right?
Well, even my thought, anybody's thoughts, not instantaneous.
Not instantaneous. It's still moving at a certain speed.
But where thought comes from, I find very interesting. I think it comes from memories. And those memories trigger new thoughts, whatever. But
yeah.
Where they come from, I think maybe it comes from God.
Yeah. Inspiration. I've always wondered, because I'm a writer of science fiction and fantasy, and where do ideas come from?
I think maybe from God, ultimately.
Yeah.
Combined with our memories, then we have thoughts.
Yes. That's I guess that's all I've got for you. But I'm curious. Yeah, I mean, what what help you need to get to your next step most.
Well, for the viewers who are watching, and for you as well, if you know a physicist or scientist, send them to the ResearchGate papers, the profile. I think I sent you that in an email or something.
Let me, I don't know that you did, but maybe you did. It's possible.
Well, in this chat session, I could send it to you if you want.
Yeah, just send it, forward it to my email if you don't mind. That would be great.
Yeah, I'll forward it to your email, because that's the key thing now.
Yeah.
As far as I can determine, that's what I was sent into this realm to do.
To get it.
Why would anybody get this kind of level of high detail, incredibly important breakthrough knowledge, only to just die without it being discovered and acknowledged? I don't think so. I think that
Yeah.
there's a purpose in all of this life, and this is the culmination of that now. So my big task is getting the word out there, find scientists to read the papers. Some of them will not dismiss it.
Right, and they'll peer review it. That's what you need is...
Checks out. And then they'll see I did additional math to prove, let's say, the constant for gravity. I did not only found a new constant called a contraction wavelength constant, but then I derived that independently, so it's not circular, gravitational constant and my constant,
Yeah.
That's not a complete system. We need to verify that relative to other known universal constants, and I did that. And I used one of my constants, then I had to verify that by deriving it using only the universal constants. And when I did that, those set of those three papers proves that this constant, this new one I've discovered, is real and is incredibly big discovery. And so I'm trying to get that information out through these shows right here and now to alert the people that there is a solution for the unified field theory.
Yeah.
And I have it, and it's of great value to you. And how so? Well, everybody wants to know where gravity comes from. Now I've described it.
Yeah.
Not only that, but we can build starships that go to stars in a matter of minutes.
Correct.
Which is the only way that's going to be practical, so that in our lifetime we could at least travel around this galaxy.
Yeah.
Stars, and we're going to find other life. We're going to find beings that are as intelligent and even more intelligent than us, and there's going to be an exchange of knowledge and more things and about religion. We're going to open up the picture and see the bigger picture, the real universe, the real world, how it works, and not just be these little tribes fighting back and forth against each other.
Yeah.
We could learn to join, to be part of the universe, join our brothers and sisters in exploring the universe, learning new things, and hopefully get out of this idea of war, which is
so toxic. Yeah.
idea.
Yeah.
And we've been living in that consciousness for a long time now.
Well, I mean, the whole idea of war it's just completely against the teachings of Jesus,
It's against the teachings of any spiritual, especially Jesus.
Yeah.
God doesn't want that for us.
Yeah.
It's our free will and choices cooking that up.
Yeah.
And we're making a lot of bad choices, and it's time to start making better choices, and with more knowledge from people in authority, not especially the government, but maybe from not only the spiritual realm, but the universal realm. I mean, what if we meet beings that are 1 million to 10 million times more advanced than us?
Sure.
In years? They're going to have some really good information, and it's going to be handy, and hopefully they're peaceful. Obviously, if the aliens were not peaceful, we'd be wiped out by now. They could have done it any time they wanted. All they had to do is push an asteroid into our orbit and let it hit us at 70,000 miles an hour.
Sure.
10-mile size, or which they could do easily with their anti-gravity craft, would wipe out pretty much everybody. But they don't do that. So they must not be totally hostile. Maybe there are some that are preying upon people, who knows, with all these rumors that are going around, the lizard people and all that. Maybe that is going on a little bit too, who knows? But somebody's keeping them in check, because they haven't invaded here in any way or form.
Yeah.
So I have hope that we could reach a higher state of consciousness and have peace among the people, and the way to do that is to expand our knowledge and our wisdom. And I hope that these discoveries that I made, which are incredibly big and profound,
Yeah.
or get out there so that we can start using them to do some very useful things like build hovercraft. It'd be great to have everybody had a. Yeah. Can you imagine you want to go to Tahiti?
Right.
Well, at 25,000 miles per hour, you get there in 1 hour, not 2 days like it would take right now.
Yeah.
If you're lucky, 2 days of flying nonstop. It takes a long time to go 25,000 miles. So there's a lot of benefits. Ambulances that can rise straight up, shoot straight to the target, and come right, no traffic.
Yeah.
It's down there, back. Just in a matter of a minute or two, you could load them up and bring them back, and they're in the hospital. It's going to save a lot of lives. Build trucks that can deliver supplies to countries that have been devastated by storms or earthquakes. They could be there in hours. We could build. I know a lot of people don't like this idea, but I'm in a state where there's a lot of hurricanes. I could build a hurricane killer, and it could be done fairly easy with hovercraft, bringing up panels into space, creating a blind system, maybe 2 million square miles across, over the open ocean between Africa and the Gulf of Mexico, or the Gulf of the United States. You could cool down and control the hurricane and not let it get to a 5.
Yeah.
Keep it 1, or by shading it, blocking the thing that's feeding it, which is the sunlight. This could be a very handy thing. Plus, we could drop the global warming problem. If we could drop the average temperature by 1 degree, we'd have weather like we had in the 1940s and 30s, which is a lot colder winters. That's what everybody wants.
Yeah, maybe not everybody, but most people.
That, I can make sure the ice caps go back to where they're supposed to be, or where we think they're supposed to be. But
yeah,
there's a lot of things that are possible with this advanced technology stuff that supposing there's an asteroid coming at us. Well, we know the nuclear option isn't going to work because it's just going to break it up, and then we'll have a bunch of crap hit us. We need to change its direction. And, in my book, as you know, I said the probes, we could send them up in mass, land on the surface, and they all just push it right into the sun, saving the Earth. We should have an advanced warning system now. I think we probably do.
Yeah, I think.
To the sky, and we're seeing everything that's moving and calculating their trajectory. If there's something coming toward us, we need to know early enough that we can do something about it. So it's a lot of good technology, life-saving technology, protect the Earth technology, and then we have to get off of this planet because sooner or later it's going to get bad here with the sun expanding outwards.
Sure.
That's going to be fatal. But that's 4.5 billion years from now, so we got plenty of time. But it's still, you never know. It could change tomorrow.
Yeah. No, yeah, that's true. Yeah, it's it's cool to know what you want to do with it, and that's it's
just get the word out.
Yeah.
Tell all your friends. Tell them a scientist. Send them to my website. I'll give you the ResearchGate site or my website. It also
now the ResearchGate papers that you have. Does that include everything that you've since most recently done with the AI to kind of figure out derive all the equations? Yeah.
It's about 30 papers now, and I did that in over a 3-month period, which, according to the AI, when you add up the score, is more output in physics than all the physicists together for the last century.
Holy Lord.
The discoveries are immense. They're just in such an odd position because I'm an independent physicist, and for the most part I'm not going to be taken seriously because there are literally hundreds, if not thousands, of guys just like me out there
Sure.
with really odd theories that, are not good.
Sure.
And it's understandable that physicists get probably inundated with letters from people like me requesting some consideration. But what they're not considering is, what if one of these guys is right?
Yeah.
They're going to miss it. And
Yeah.
so they are missing it.
Well, and I think, in my own life, I pray for discernment. I pray for, being able just to be a decent person. And, but, like I said, when I read your book, it really hit me. And I just, I think it's the correct theory.
Well, yeah, and share the book, recommend it, and
Yeah.
a review.
Yeah.
That stuff helps, and basically I need to build momentum.
Yeah.
Trying to use the media. Einstein didn't have this. Lorentz, Maxwell, all of this didn't exist. So I'm trying to utilize this, doing shows like this, so forth, to get the message out there, to maybe guide the
Yeah.
physicists, looking for some physicists to take up the banner and be a mentor, and get this ball over the goal line.
Yeah. And, and again, just so I'm completely clear, my channel is not at all targeted towards this subject matter, but I personally have an interest in it, which...
Your people are going to have an interest, so...
Yeah,
It takes one. It only takes one.
Yeah.
The right person to make this happen. And that's what I'm looking for right now, is a connection.
So are you going to start, building a model or something, or have you, or what's your plan, to make it real?
I'm doing testing, and we'll put that testing on, unless I get told not to do it by who.
Sure. Yeah, or have you looked for funding, for that, or?
No, because then people get, well, he's only in it for the money.
Mm-hmm.
I can do this on my own.
Yeah.
It would be helpful, if somebody gave me a job to help them build a starship. I can do that.
Sure.
I can do that today.
Yeah.
But I'm working on finishing up the math. I have much more confidence about that when I have these next two papers written.
Sure.
Just 2 more to go. Then I have like a complete set that explains everything in the physical. And I mean, that book that I titled, that name now turns out to be perfect. Because I literally mastered reality. This reality, and not all the others.
Yeah.
Just this one.
Yeah.
Is enough. And it's taken a lifetime to do it, but turns out all these years the person I was waiting for turned out to be me.
Makes sense.
I never thought of that. I never really thought of that. I thought I would read somebody else to make a discovery, but it just sort of happened.
I mean, I think, that's, if you don't see something out there that you want, like, well, then I'll make it, right?
Yeah, like kind of the thinking there, and just
or discover it, or research it, and
it happened. It was predicted to happen, and I kind of gave up on it over the years as it was taking so long, and I thought, oh well, maybe it was a mistake, and then suddenly it happened. Fiddling around with the AI, and it starts coming up with right answers, and I'd say, hey, wait a minute, let me cross-check. And it kept checking out, and I tried multiple AIs, and I had them check each other and check my papers. And
it's amazing. Yeah, it's really amazing. I mean, it's, that the electron...
AIs are powerful physicists.
Oh, yeah.
Any physicists are run for their money.
that the electron
With
is...
the right information, they can do amazing things. This AI revolution is, people have no idea. And this will really hammer down how important AI technology is. Because this is giving the United States, if I can wake them up, this is giving the United States a great advantage over the rest of the world.
Sure.
Technologically speaking. And hopefully you will join us. We could all join together and be peaceful at some point. That's what I'm praying for.
Yeah.
If push it in that direction, that'll be great.
Yeah, I mean, I'm a pacifist myself. You know, I don't, you know, I'm a follower of Jesus. You know, so yeah.
Me too.
But thank you so much for your time. I really appreciate it. You know, if there's other questions, I can't imagine you have any questions for me, but you know, if there's other things that you want to talk about, let me know.
Yeah, maybe some other time you cogitate on all of this stuff and you come up with a few more things, we could have another discussion. I'm always open for a good discussion.
Yeah. No, thank you for, you know, for entertaining me and letting me ask you, you know, my questions. I really appreciate it.
Alrighty.
Okay. Well, keep in touch. Great talking to you, Mark. And
Hey, Tom.
let me, now how do we end the actual recording?
I will do that.